Today we're going to look at example 6 using a trend line to find the formula for a numerical derivative out of section 3.2 numerical derivatives and limits from business calculus with Excel. The idea is to figure out the function and its numerical derivative, graph, and use Excel's trend line to produce a formula. So we're going to look at example 6 and it's set up with a function already given us and the setup that we've been doing for the last couple of examples. So if I look at my formulas, I have x plus delta x, our standard delta x is 0.001, x minus delta x is going from -6 to 6 by 0.5, f of x is that function that's listed there. I've got it evaluated at particular points. I've done quick fill to fill in for f of x plus delta x and f of x minus delta x, and then the numerical derivative is the difference of these two divided by twice the delta x. So that gives me the difference quotient. So having this, I'll be able to plot x, f of x, and f prime of delta x. So we take care of this, which is essentially what we've been doing in the previous example. And now I simply highlight the column for x, hold down my command key, highlight the column for f of x, and highlight the column for f prime of x. I'm going to want to insert a chart. I'm going to insert scatter plot smooth. I can see my f of x and I can see my f prime of x. I'm going to make my formula larger, make my graph larger. But what I'd like to do is have a formula for this graph here. And so I'm going to do it as we've learned before. I'm going to add a trend line. And that looks like it's a linear function, so I'm going to add a linear trend line. But I'd like to display the equation on the chart, and there I see the equation for me. So I've displayed it on the chart. I'm going to make it so that that's actually a size I can read. And so in this case, the formula for my derivative is 4x plus 5, where my initial function was 2x squared plus 5x minus 7. So that's how I can produce a formula. For the second version of the same example, we're going to make this more general. And here I have A, B, and C. I have parameters in here. I've got some parameters in here. When I look at my formulas, notice that my formulas use the parameters, so $F $1 means I really mean A there, and that's going to stay that's going to stay F1 all the way through. My B is $F $2, and my C is $F $3. And so this case is now set up so it works with whatever my parameters are. I'm going to do what I've been doing, which is I'd like to see the graph of x, f of x, and f prime of x. I'm going to insert a scatter plot with the smooth lines on it, make it a bit larger. Now, one of the reasons for the parameters is I now could change my function, and when I change the function, it changes the function and the derivative. But again, I'm going to do the same thing. I'm going to look at this and add a trend line. I'd like a linear trend line. I'd like to display the equation on the chart. I'd like to look at that label and make the label big enough for me to read it. And so I see when the original function was 2x squared plus 3x minus 7, the derivative is 4x plus 3. Well, that makes me curious because I don't see a 7 showing up, and so I'm going to ask what happens if I change 7 to 9? Doesn't change the derivative. If I change 7 to 2, it doesn't change the derivative. If I change it to minus 23, it doesn't change the derivative. So that constant doesn't seem to have any impact. Now I'm going to look at what happens if I change it to 5, if I change it to 9, if I change it to 1, if I change it to 11, and it seems the constant term of the derivative was the linear coefficient of the quadratic function. And so I'm now looking at the linear term of the derivative. 2 gave me 4, 3 gives me 6, 4 gives me 8. I'm going to guess that this should be twice whatever that derivative is. So if I do 23, it should be 46. And if I do minus 5, it should be minus 10. And so I think the derivative I'm getting for ax squared plus bx plus c is going to be 2ax plus b.